Okay, the next speaker is Cohen. He was supposed to talk about something else, but he switched the topic. So he will not show us how to empty an ATM in 15 minutes. And you won't get fast cars and everything.
Okay, go to Twitter.
Okay. So his next talk. We still have some space, so I'll fix that. 15 minutes.
Yeah. Thanks, Guy, for the introduction. My name is Cohen, and I'm the pre-sale engineer of Cybertinel. And in this session, we'll be walking the path of a cybersecurity analyst in a big organization and just uncovering the tip of the iceberg of how do they uncover advanced threats. So let us begin. Monday morning, getting into the office and drinking some coffee, hanging with the guys, and I sit in front of my security dashboard systems, overviewing the alerts, when suddenly I'm overviewing the Snort IDS, and I see that there has been a successful attempt reaching one of the public email vendors out there. So a specific endpoint is reaching this specific public email vendor. Now, what we can see that there is a repetitive pattern. So each and every 4 hours, this specific endpoint is communicating with the public email vendor. So basically, something smells fishy. Monday afternoon, I start the investigation. By now, I suspect that perhaps the next session should occur around 12 o'clock. Of course, I ask the user whether he did this manual attempt, whether he reached the open Gmail account, and I look over the browser's history and cache, and I do not find records for it. So I start deploying my tools. I deploy Wireshark to stick the network, CCTL's great tools, Process Monitor, Process Explorer, and TCP View. And basically, I'm doing monitoring for 1 hour long. And I found nothing, no suspicious process, nothing trying to communicate with this specific public email vendor. Okay, so I do a reboot to the station. After 5 minutes, I get another IDS alert. Something has just communicated with the public email vendor. Seems suspicious. Again, I deploy the tools. Again, for certain monitoring, I don't see anything. Again, I do a reboot, and I get this IDS alert. So perhaps something has some hiding technique preventing me from overviewing it. So I decided to use some of the so-called heavy tools. I'm basically doing an MFT dump, seeing all the files ever created on the operating system, as well as the directories. Specifically, what I'm looking at are the file's location and the file size. And I'm trying to compare it with Windows API. Of course, I don't do it manually. I do have my all-beloved Python scripts to compare it. And I do find mismatches. Certain files which should exist on certain folders are not there. A simple test I'm doing, I'm just archiving this folder, and I do find the missing file. Seems odd. I dump it back to the station, and it goes missing. I don't see it in the Windows Explorer. Another test I'm doing, I'm dumping the file with a different name. And yet again, I can see it for now. I try to kill the process by name, and I get an access denied. Something strange. So, chapter 2, the breakdown. It's Monday night by now, getting into my laboratory, and I'm taking the file, trying to make life easier. I simply dumped it into a sandbox using a sandboxy, and the process is terminated after a few moments. Seems odd because before that we saw in the IDS that this specific action has occurred for several hours, so how could it be that it has terminated? So I decided to investigate the binary. I tried to PID just to see if there is a packer, and I see that there is an Empress packer, just so happy to be unfamiliar with the family. And I'm starting doing some static code analysis using IDA, and I see the imports, exports, and so on, but deciding to do the investigation using OllyDBG, doing dynamic code analysis. And long story short, I'm able to get the .NET unpacked binary. I'm getting to the entry point and dumping the .NET binary. And actually, it's quite nice because from the .NET, I can very easily reach to the source code. So altogether, it was a successful day, unless there was an obfuscator. On Tuesday, when I opened the code in Reflector, I see there is a code obfuscation. And on top of that, there were some encrypted resources, supposedly a bitmap image and a byte array, which are not. Once I dump these resources, they are not what they're supposed to be. I get back to the obfuscated code, and I do find these functions which are supposed to decrypt these resources. I'm building a wrapper, basically, and I'm able to get the clear decrypted result. As you can see, there are two legitimate tools out there and two stubs, one suspicious exe and a stub. On top of that, Reflector is quite nice, allowing me to get a Visual Studio project out of it. So for now, I do have the clear text code of the Trojan, of the tool. Tuesday night, I'm kind of already investigated the entire code, so we have a complete tool workflow. This tool, I must say, it is has quite logic scheme. It's making everything ready, making sure no one's looking at it, then prepare the environment, and then starts the exfiltration of data. So first of all, it does identify the security applications. What it does, as the first function I saw, was to detect emulation. You're going to throw it to OllyDBG. What it does, it's creating basically a clock and start ticking. The thread now goes clipping. And now imagine you are debugging with using Olly. You are just having even a millisecond of delay between these two lines, and there is a time difference. So there will be a system exit once you get to this snippet. And you won't be able to advance. The payload won't be executed. Later on, there is a sandboxy detection. This was the reason that I just threw it to a sandbox, and again, I didn't see anything. When I did the investigation on the infected endpoint, then there was a Wireshark module detection. It was basically looking at the task manager, looking for the title of the process. Again, it has exited. There were additional modules. I didn't put them all in here, but also WinSocket packet editor. And also, this tool was looking for firewall and antivirus using basic WMI queries, just to know where is it living. It was doing some disablements, lowering the UAC settings, security settings, also disabling the task manager, the command prompt, msconfig, and registry edit. So everything is kind of prepared. It's know where it's living. And it starts to protecting the Trojan itself. So first thing it does is elevate the process privileges using the set kernel object security. Afterwards, what it does, it is registering itself as a critical process. So you cannot basically kill it. Also, it is hiding the file, also as a hidden file and a system file, so there are two checkboxes to untick. And it is also creating a boot persistency mechanism, and it's quite small, but there is a KZ rootkit module integrated in the solution, in this Trojan. So KZ rootkit is basically a packer or crypto you can buy off the internet. You can see some discussions, people like commenting the developer what a great product it is. And since I got the source code, I'm able to sell it at half price later on. So reach me afterwards. And then what it does, it is spreading. If you are connecting a mass storage device to the computer, it will look it will create an auto-run key, and then dump the payload there. So everything is kind of set up. And now actually begins the fun stuff. It has keyboard hooking, taking basically all of your keystrokes, and then it does clipboard hooking, all the Control-C and Control-V's. And also it has a screen capture mechanism. So these are kind of common, you may say. A new thing I personally saw was the Bitcoin wallet stealing. So it is looking for a Bitcoin wallet and will steal it off as well. It has additional multiple modules, such as get the external IP address, getting the external IP address of this specific endpoint. And it has multiple exfiltration techniques, all from the network vector for this specific tool. As you can see, it has a FTP capability, as well as uploaded to a PHP basic web service mechanism. But what actually it used, as we saw in the IDS, it has used an email exfiltration vector. Now, I'm getting to this code section, and I wonder, where does he get the credential? It cannot be hard-coded. There is no way he did it. Perhaps it's contacting an external web service also. But yeah, it is encrypted inside the code. It is hard-coded. And I'm able to reverse it and get into the clear text credentials. Now, by this point, you must remember it's Tuesday night. I'm after several hours of investigation, and nature calls. So I'm rushing to the toilet, getting back, just to find out that someone beat me to it. 2 minutes ago, the password has been changed. Unluckily for me. But altogether, I think it was quite a successful investigation. I was able to detect the tool from the IDS, do a manual investigation. Luckily for me, it was a .NET binary, so I was able to get to the source code quite easily and to get all of its techniques and what it was looking for. I must say in this time that we as Cybertinel are doing all of this analysis manually, automatically, under 2 minutes, besides of the MFT dump, which takes time. And yeah, you're more than invited to come discuss us about the targeted ATM attack, which we could not disclose in this session. Thank you. I was Lee. Have a great day.